All right, we're back with problem 1.27. C, in the last video I called it either D or B, but it's actually C. And we established that it is not time invariant. So we're going to write a no here. And I'm also going to correct the fact that that is spelled wrong. Should be A-N-T, I believe. And now we're going to check to see if it's linear. Now, when we talk about linear, when we talk about, say, a linear system, well, if we have some input x3 of t, that's just saying that x3 of t is some scaled superposition of two other inputs. So we could say a x1 of t plus b x2 of t, where a and b are constant coefficients. Now, a and b could be um, complex, they could be real, they could be purely imaginary, but they're still going to be constant coefficients. And what we want to know is that the response to, so if it's a linear system, the response to a times x1 of t is a times y1 of t, where a is any complex constant like we just talked about. And the response to x plus 1 plus x plus 2 is y plus 1, y of 1 plus y of 2. So x3 of t is going to give us our output y3 of t, and that's equal to the integral from negative infinity to 2t times x3 of tau d tau. And now we can swap out x3 of t. So we have the integral from negative infinity to 2t of ax1 of tau plus bx2 of tau. And this comes from our relationship that we defined here, right? Try to keep it as neat as possible because I can get kind of messy. And that's all integrating with respect to d tau. And we could move some stuff. We can multiply in the d tau, and when we multiply in the d tau, this right here is associated with the d tau, so that'll multiply in as well. And then we could separate them. So we'll have from the integral from negative infinity to 2t ax1 of tau d tau plus the integral from negative infinity to 2t of bx2 of tau d tau. And we'll do one final step. We have a minus infinity 2t x1 of tau d tau plus b times the integral from negative infinity to 2t x2 of tau d tau. And right here, if we look at this right here and this right here, well, we know that that's equal to a times y1 of t plus b times x2, or excuse me, times y2 of t. Because from our from the given information, all we're doing is adding those subscripts. So this system is linear. and I think you have to have already taken linear algebra to take this class, so you should know. You should be able to kind of just look at that and recognize that it is linear because integration is a linear operation, just like differentiation is. And for if we're in DT, um, if we're in DT, then summation is analogous to linear, is analogous to integration. So summation is also a linear operation. All right, I'll be back. I'm gonna do memory, causality, and stability in the final video. Thanks.